Example 1.3. The charges and coordinates of two charged particles are held fixed are Q1 and Q2. Q1 has 3 microcoulombs of charge with coordinates of 3.5 and 0.5 centimeters. And charge 2 is equal to minus 4 microcoulombs at location of minus 2 and plus 1.5 centimeters. Find the magnitude direction of the electrostatic force on particle 2 due to particle 1. The charges have an attractive force. And is graphically shown as follows. So I'm going to look at my y-axis here. I'm going to do like this. So this will be my y-axis. And this is in units of centimeters, which is not good to use. And so when I'm looking at this, I'm going to set this to be my x-axis right here. And we might have to modify this. So I'm going to say that each 2 units is centimeters like that. And then x here, I'm going to do the same thing. 2, 3. I'm going to have to extend this a little bit more. Well, this is not straight, but it'll be good enough. And then we're going to do 4 here. And this will be units of x in centimeters. And then this will be -2, -1, and of course, this will be our origin. So when I look at my charges, I could see that charge 1 is at 3.5, right? This guy's at 3.5, and it's 0.5 centimeter up, so it's going to be right here. So this is going to be charge 1, which is Q1. Then I'm going to have charge 2, which is at -2, 1.5, so it's going to be right here. And this is a negative charge, which we call Q2. So we want the force of 1 acting on 2. So that means if I look at this, I have a force that goes from center to center. I'm going to have a force that's going to look something like this. It's going to come here, and it's acting on a straight line from here to there. So this right here is the force 1 on 2 in that direction. This is what we're trying to calculate. We want to calculate that force, and we want to calculate that magnitude. So when I'm looking at the direction of this, we're seeing here is that this guy, this angle right here is the angle that we are interested in, which I'm going to call theta 1, 2. So the direction of the force is theta 1, 2. Okay, let's do this. to calculate the magnitude and direction of F12, we need to calculate the displacement R12 first. So let's look at the displacement vector. According to what they told us on the question, we have, so what we want to plot those vectors. So we want to plot vectors R1, R2, and R12. Now note that that vector has to be in the fourth quadrant. So we're expecting an X component to be in that quadrant. So I'm actually going to pirate this question, this image, and bring it down here and modify it so we don't have to redraw it again. Okay, so let's say that we place that right there. So here's what we need to do. I want to get rid of these forces. Right, so here's what we have right here. So what are my vectors here? The first vector I want to pay attention to is vector R1. So if I look at R1, it's going to be the vector from here to here. And this is vector R1. And if I look at vector R2, then I'm looking at this guy. And this will be R2, so that the vector from 2 to 1 is what we are calling in this direction. This is the vector 1, 2. And this one, again, points in the fourth quadrant, where again, this angle is 1, 2. So now that I have that, I need to write out the components. So let's look at that. So if I look at my vectors, I need to convert them into proper units. So I know that I have R1, and they give us to them in centimeters, so this will be 3.5, 0.5 centimeters, but then I'm going to convert them immediately into meters. That's proper units. So if I do the same thing with R2, they gave us minus 2.0 and 1.5 centimeters. So in proper units, this will be minus 0.02, 0.015, and now it's in units of meters. So if I look at this thing here, then my displacement vector, R12, which is R1 minus R2, gives me values that then read 0.055 and minus 0.013 meters, and this is my vector in the third quadrant. And this is what we needed right here. So again, as a check, this points in the third quadrant, which is what we had to have. So now I need to get the details of this thing. I need the magnitude direction. So calculating the magnitude and direction, I see that the magnitude of R12 is then going to be R12x squared plus R1y R2y squared square root. And when I put in my numbers here, right, I'm going to get 0. Maybe I should put in the numbers. And I'm going to get minus 0.01 through 3 squared. And that gives me a value of 0.056 meters. And then my direction, theta 12, should be the tan inverse of R12y, R12x. And if I compute this, I got to remember that which quadrant this is supposed to lie in. So that angle has to be in the fourth quadrant. So I'm going to get minus 10.3 degrees, which I will approximate to 10 degrees. So now I have my vector form, which then tells me that I12 is then going to be equal to a magnitude of 0.056 meters and an angle of minus 10 degrees. And when I say that that's from the x-axis, so once again, in different notation, I see I have that vector. So I have it in components and I have it in vector form. We typically do everything in vector form. So now calculating the Coulomb force, we then say that our magnitude is then going to be 4 pi epsilon divided into 1, the charge of 1, the charge of 2, divided by their displacement. Now putting in my numbers, I'm going to get 8.99 times 10 to the 9. This is Newton meter squared, Coulomb squared, times 3 times 10 to the minus 6 coulombs times 4 times 10 to the minus 6 coulombs, coulombs, and then my distance between them is 0.056 meters squared. Checking out my units, I could see that the coulombs cancel as well as the meters squared cancel. So then I have a value here that reads 35 newtons. Now I'm going to move this over here a little bit. So if I look at the direction of 1, 2 is the same direction of theta 1, 2. So we know that this is minus 10 degrees. So in other words, our force here, our 1, 2 force, has a value of 35 newtons and an angle of minus 10 degrees. So let me see if I still have my, so if I come back and I grab the image that we drew before, right? So if I put this in here again, just one more time, so I went back up and I stole that image. Here's what I'm seeing here. This magnitude of the force here has a value of 35 newtons. So when I look at the angle has to be in that third quadrant. We could see that the angle between here and here, that is 10 degrees.